Welcome to Chemistry White. Today we can see the operators in quantum mechanics. The operator is given the symbol for particular mathematical operation. It will transform one function into another function. Example, d by dx. It means d by dx is a operator. It has no value when it is stands alone, but when we put it on the function x square, it becomes d by x square. D by dx x square equal to 2x. Here x square means differentiation of the 2x. So we get new function, this x square function converted into another function of 2x. So d by dx is the operator. It is called operator. First one, types of operators. First one, commuting operator. If we have operator A and operator B, or A cap and B cap are two operators, the conditions there, operator A, operator B is equal to operator B and operator A. It becomes A operator B operator equal B operator A operator. Here A operator and B operator are commuting operators. For example, the operator A cap equal K, another operator B cap equal to d by dx, and the function is fx equal to sin x. If we apply the first condition, operator A operator B plus x, it gives, or it means when we firstly operate the function fx with the operator B and then operator A. See, operator A operator B fx equal, it gives k d by dx sin x. Here k is clustering, then we will get the differentiation of sin x is, it gives k cos x. The whole equation becomes operator A operator B fx equal to k d by dx sin x equal to k cos x. If we apply the second condition, it means when we firstly operator or first operator with A cap and then with the B cap, then we will get operator B operator A fx equal d by dx. It becomes operator B operator A fx equal d by dx k sin x. Totally this equation becomes operator B operator A fx equal d by dx k sin x equal d by dx k sin x. If we solve this value is same, that is k cos x. It means both conditions we get the same result. So let's say that therefore operator A operator B equal to B operator and A operator. These two operators are commuting operator. Guys, if you don't understand, please see again this video. It is easily my own writing lecture. Second one, commutators. What is the commutators? If operator A and operator B are two operators, then it is possible to construct a new operator AB minus BA. It is denoted by below the sign or symbol A comma B. The A comma B symbol is commutators. It will be equal to AB equaled AB minus BA. It will be 2 operator A operator B, sorry, okay, operator A operator B minus operator B operator A, that is AB equal to AB minus BA equal to operator A operator B minus B operator A operator. For example, if the two operators commute, then we will get AB equal to AB minus BA equal to operator A operator B minus operator B operator A equal 0. This commutators stands for multiplication with 0. So memory this. Third one, linear operator. What is the linear operator? If operator is A operator, it is acting on the sum of the two functions below like this. First one fx, second one gx. It forms fx plus gx. It means the conditions there operator A, the sum of the two functions fx and gx is equal to sum of the operating A operator B or two these are functions separately. It means operator A fx plus B operator gx both are equal, then the operators known as the linear operator. Example, d by dx is the linear operator. How we can prove it? Please just think it. Let's see, the operator is d by dx. It becomes operator A equal to d by dx, and then first function is x cube and second function is sin x. Now the first condition, at first conditions on the left side, see the left side equation, first conditions on the left side. The first conditions are the first conditions on the left side, we can write it become like this: operator A int fx plus gx close the bracket, then they put this value in this, so operator is d by dx, fx is s cube and gx is sin x. So this equation becomes d by dx into x cube plus sin x. The differentiation of x cube will be 3x square while the differentiation of the sin x will be cos x. We get the value 3x square plus cos x. So total equation becomes d by dx into x cube plus sin x equal to 3x square plus cos x. Now let's see right side. We can write both the functions separately. It means operator a fx plus operator a gx. In this value we get d by dx x cube plus d by dx sin x. When we take differentiation separately, d by dx x cube plus d by dx sin x, so we get the value 3x square plus cos x. The total equation becomes a operator fx plus a operator gx equal d by dx x cube plus d by dx sin x equal to 3x square plus cos x. Here both values are same. It means left side equation equal to the right side equation. So d by dx is a linear operator. Please remember that. Next one, fourth, vector operators. What is the vector operators? The vector operators is a differentiational operator. It is denoted by this symbol. See the symbol. It is differentiational Cartesian coordinates. The Cartesian operator means it is a differentiational operator. Symbol, see the symbol. So the vector operator is equal to I. It is becomes the symbol equal I vector del by del x plus j d by del by del y plus k vector del by del z. Here here I, j, k are unit vectors in the x, y, z direction coordinating system. Example, vector operator is the Laplacian operator. It is called vector operator is also called Laplacian operator. It is used in Schrödinger wave equation. Next, fifth one, hermition operator or hermition operator. What is the condition for this operator? See the condition. Where are operator which satisfy the below the condition. Here condition is very important. So integrate psi I star operator a psi 2 d dou equal integrate psi 2 operator a sin 1 star d dou. Left side is first condition, second right side is second condition. The first condition, in the first condition the operator a cap psi to this function and multiply integrate side 1 star with this integrate for second condition or right side. The operator a cap sin 1 this function and multiply integrate psi 1 star with this integrate. Here both are equal. It is called hermition operator. Actually hermition operator is the linear operator. For example, operator a equal d square by dx square. The hermition operator is d square by dx square it will take the operator A. Sorry, please note this in this place. This is d square. I written mistakenly. Next, for first wave function or for first condition, psi 1 equal exponent ix. For second wave function or second condition, psi 2, psi is wave function, psi 2 equal cos x. Then we, when apply the first conditions, we will get, put the values all of these, we get integrate psi star A operator A psi 2 d dou equal integrate exponent ix star d square by dx square cos x dx, and by solving this with the integrate we get equal minus integrate exponent minus ix cos dx. This is the first equation. This is for the first condition or first equation. For second condition or second equation, integrate psi to A psi 1 star d dou equal minus integrate cos x d square by dx exponent ix dx, and by solving this with the integrate we get like this equal minus integrate cos x exponent ix dx, it becomes equal minus integrate exponent minus ix cos x dx. This equation is 2. Here first and second equation both are equal, so this operator is hermition operator. What is the property of hermition operator? The eigenvalue of the hermition operator are real. The eigenfunction of hermition operator with a different eigenvalue are orthogonal. Here see operator A, it gives sin 1 convert to lambda 1, sin 2 convert to lambda 2. Here operator A is hermition operator. These are two eigenfunctions. Psi 1 gives psi 1 and psi 2 gives psi 2, sorry, lambda 2. Sorry, psi 1 gives lambda 1 and psi 2 gives lambda 2, but both are different eigenvalues. It means eigenfunctions psi 1 gives eigenvalue lambda 1, eigenfunction psi 2 gives eigenvalue psi 2, sorry, lambda 2. Here psi 1 and psi 2 are orthogonal. Psi 1 and psi 2 equal to orthogonal. It means integration of psi 1 star and psi 2 d dou will be equal to 0. So integrate psi 1 star psi 2 d dou equal to 0. Next one, sixth one, eigenvalue functions and eigenvalues. If an operator acts as a well behaved wave function, what is the well behaved wave function. Please note this carefully. See the definition. Well behaved wave function means when it is infinite value, single value and continuous, it is called well behaved wave function, and generates same function and multiplied by constant. This constant known as the eigen value and this function known as the eigen function. Here operator A psi equal to E psi, this is the eigen equation. Here operator A gives, here operator A is the operator, psi is the eigen function, E psi is the eigen value. For example, operator d square by dx square, it is acting on wave function sin x. Then we will solve this value, we get the result d by dx m cos x mx, and we take differentiate it again when we get equal minus m square sin mx. Left side is this constant value is eigen value, right side is this is the eigen function. Next 7-1, normalized wave function. What is normalized wave function and the conditions? First we will see the condition. When conditions integration of psi I star d dou equal 1, it means any wave function psi and it is complex conjugate of psi star, it is integration equal to 1. Then such wave function is now normalized wave function. Psi I equal normalized wave function. Here any wave function can be normalized by multiplying it with a constant, this constant called normalization constant. Here if psi equal normal wave function, c equal normalization constant, so when we can multiply this psi with c, then we get the result will be c psi equal to normalized wave function. 8-1, orthogonal wave function. What is the orthogonal wave function? If the two wave functions are psi 1 and psi 2, the conditions that if we take integrate f psi 1 star psi 2 d dou, or we integrate f psi 1 psi 2 star d dou equals 0, thus integration psi 1 star psi 2 d dou equal to integration psi 1 psi 2 star d dou equals 0. Here integration equal to 0. This type of wave function is called orthogonal wave function. Example, if we take psi 1 equal sin x, then if we take psi 2 equal cos x, and the integration of limits 2 pi 0 below like this, integration 2 pi 0 sin x cos x dx. Now we multiply and divide by 2, and this equation will be formed integrating 2 pi 0 sin x cos x dx equal 1 by 2 integrating 2 pi 0. We know that the value of 2 sin x cos x dx became sin 2x dx. So this equation also will be formed below like this, equal 1 by 2 integration 2 pi 0 sin x 2x dx, and integrating this we get equal minus 1 by 2 cos 2x 2 pi 0. The value of cos 4 pi is equal 1. The value of cos 0 is equal 1. So this is equal minus 1 by 4, 1 minus 1 equal 0. The total equation becomes integration 2 pi 0 sin cos x dx equal 1 by 2. The integration 2 pi 0 2 sin x cos x dx, so equal to 1 by 2 integration 2 by 0 sin 2x dx equal minus 1 by 2 cos 2x 2 pi 0 equal minus 1 by 4 cos 4 pi minus cos 0. The net result is 0. It means the two functions are orthogonal and wave functions. Ninth one, orthogonal normal eigenfunctions. When psi 1, psi 2, psi 3 are different eigenfunctions such that each of them is normalized. Example, integration psi I star psi I d dou equal to 1. It means integration of psi I star psi I d dou equal to 1 if any of the two functions are orthogonal. For example, integration psi 1 star psi j d dou equals 0. It means integration of psi I star psi j dj is equal to 0. Here psi 1 is any of the wave function. It means psi 1. Psi j is maybe psi 2 or psi 3. These types of wave function is called orthogonal wave function. This lecture is over. So we saw the all about different type of operator and eigenvalues, the eigenfunctions, and all these terms in this type. Please subscribe the channel and share. Thanking you all.